Okay, so after some technical issues, we are finally there. So yeah, I welcome you to another part of our Lunch and Learn series. If you have already been part of earlier ones, we did at a theme of modernization that we drove through the last ones. And we did this with Fresh and Arcade and PCAS and gave some insight on which toolings and tool sets and methodologies were available just to do modernization, and also especially around IBMI. So today, this is a very interesting topic, and I found it really interesting also to have the preparation discussion here with Kaare from GiAPA, because it's about application performance monitoring, right? So the tool from GiAPA does not only does the performance monitoring, but also gives you hints where you can fine-tune and tweak your applications. And I haven't seen something like that before, and I do think this is another hidden, very well hidden gem within our ISV ecosystem that everybody should be aware of when talking to being a client or talking to clients or being a business partner and or an ISV. And this is how this all came together. So with that, maybe I'm just make a short introduction to myself. My name is Simon Porstendorfer. I'm running the ISV ecosystem within the Power Europe team. And with me today is Kaare from GiAPA. So he will take us through the functionalities and the capabilities that you have with that with the application performance monitoring tool. Plus, I do think at a later stage, we also have Bo Rasmussen, who does a lot of performance tuning from lab services from IBM, and will probably give you some insight as well. Yeah, with that and not wasting any more time, I will hand it over to Kaare to take you through his pitch.
Okay, thank you. I'll see if I can share my screen. Do you see a screen now?
Yes, Kaare. Perfect.
Okay, so we go. Very welcome to this presentation. A very brief introduction to myself. What is my background in performance? Well, I always thought it was fun to make programs run fast. It has always been a kind of a sport for me. And I have actually been teaching at IBM education centers in teaching performance in 24 countries. So that gave me a bit of background. But enough about that. Let us go and see what this is all about. It's called Global iSeries Application Performance Analyzer. iSeries now IBM, something running under IBMI, but we don't change the name because of that. So let's go. This tool enables management, operations, and development to follow up on virtually everything that runs on an IBMI. GiAPA enables operations to follow up in real time what happened on the server, tracing use of all resources, and display results statistically and graphically with trend charts, etc. Development can verify if the applications run efficiently, locate any optimization potential, and use GiAPA for quality control on new applications. And we develop it. We are our company name is iPerformance. We are a Danish IBM business partner. I will use here something like 4 or 5 minutes to give you a little global information about the product, how it's working, what we're doing, and then we will turn to see our new fully automatic performance analysis where it produces results by itself. So IBM has some, as we all know, some very powerful tools for analyzing performance. Therefore, GiAPA obviously had to offer something additional and different in order to be considered at all. The IBM tools are normally only used to analyze applications when performance is unsatisfactory. The analysis is targeted against a certain job and is very detailed and therefore also a bit resource intensive. Retrieving information may be every millisecond. It was never intended to be used to look at all jobs all the time. GiAPA is based on sampling, fetching performance data for all jobs and tasks, but not but only every 15 seconds. This has proved to be sufficient to catch probably more than 80% of all performance inefficiencies within the applications running on IBM I. GiAPA processes the resource usage data in real time, calculating, amongst others, how much CPU each job used within the last 15 seconds. If the CPU usage exceeded 4%, GiAPA will also collect information about which programs are running and which files are accessed, down to the statement line number or relative record number used. This enables GiAPA to document which program functions were used and how the databases were accessed for all jobs using any significant amount of resource. The goal with GiAPA was never to reinvent the wheel. It was not designed, for instance, to locate hardware bottlenecks. IBM has very strong tools to do that. For the same reason, GiAPA does not analyze the efficiency of SQL statements, but GiAPA can, of course, see if SQL accesses tables inefficiently. Some claim that CPUs are so fast now that application performance is not an issue anymore. The reality is that there has been a huge increase in the number of records to process. The CPU cycle time in nanoseconds is impressive, but disk IOs are still slow in comparison, and programs often have to wait for physical IOs. Even the logical IOs, only transferring data between the data management buffer and the program work area, carry quite some overhead. IOs are responsible for around 75% of the time used by commercial applications, so any savings here are very rewarding. One example, a weekly batch job made slightly more than 4,000 million logical reads. The number of IOs and the time used could be seen by any performance tools. But with the GiAPA's analysis of how the files were accessed and which records were used, it was evident that the majority of the reads were either inefficient or superfluous. The resulting savings were remarkable. To our knowledge, GiAPA is the only tool also collecting information about which individual records are being accessed. Pairing this with the general object description data for the files and the IBM I/O access methods used seems to give GiAPA a major competitive edge when it comes to pinpointing optimization potential. Speeding up program performance by modifying source code is generally considered a complex task. However, in most cases, the change needed is minimal because the main logic of the program, the complicated part, so to speak, remains untouched. Normally, only a single or very few statements have to be modified. To identify exactly which program source code line must be changed and how, that most often requires expert knowledge. GiAPA was created to deal with exactly that problem. GiAPA identifies where resources are used down to the source statement line number. An explanatory text will describe the delay and suggest more efficient alternatives. The IBM Performance Collector API transfers detailed resource usage data for all jobs running to GiAPA every 15 seconds. By processing this data immediately, GiAPA can warn the system operator, for instance, if a job is looping or using too much workspace. Since GiAPA stores data for all jobs, it is not necessary to specify the job to focus on. GiAPA detects which jobs use the most resources on the fly. As already mentioned, GiAPA will automatically collect call stack and file usage data when a job uses excessive CPU. Doing so, GiAPA normally detects optimization potential in applications believed to run efficiently. Our trade secret is probably the way we manage to collect and store so much data and still only use less than 0.1% CPU. We achieve this by storing the data in a compressed binary format. We are using field lengths in bits, so we occupy very little space and therefore use surprisingly few IOs. This field length in bits, an example, job IDs, as we all know, are 26 bytes. We store them on average in 25 bits. And of course, they're still unique. Therefore, our customers run GiAPA 24/7, meaning that data always is available to analyze any incident at any given time. Automated performance analysis was GiAPA's original objective, and that requires very detailed data. The result is a true goldmine of resource usage information, useful for much more than program optimization. Back in 2003, when GiAPA was originally designed, the GiAPA menu only had a fraction of the current number of options. Thanks to our customers, who have provided us with many great ideas on how to improve our software, we added more advanced ways of analyzing performance, new reports, diagrams, GUI interface, and much more. Needless to say, our software is constantly being improved and updated, and we continuously welcome suggestions. Learning how to use GiAPA is very easy. Tutorials are available on the GiAPA homepage, and they'll teach you how to use the different options. In this presentation, we'll only show 2 examples of the results of our most advanced function, where GiAPA automatically analyzes the collected data and generates pages indicating which programs may be optimized, what should be changed and how, and estimates the obtainable savings. The inspiration to attempt developing fully automatic performance analysis came from IBM revealing how artificial intelligence is used to enable Watson to list possible diagnoses based on a number of symptoms. With no doctors typing in possible symptoms, GiAPA had to find them automatically. This was feasible thanks to the unique and very powerful IBM I operating system and all the APIs. Having analyzed performance issues from hundreds of servers over more than a decade, we had sufficient data to construct tables of symptoms indicating less than optimal performance. So here we go, the first example. Our objective was to generate 100% self-contained documentation, not requiring explanation and covering the vast majority of commonly seen inefficiencies within application program code. In the analysis of programs, GiAPA identifies what activities in a program consumes the most time accessed across all jobs using a program, not only based on long-running jobs, but also when a program maybe is only active for a minute, but used in a high number of jobs. Here we demonstrate a time-consuming function. We indicate, and now I hope you can see my cursor, we indicate here in the second line the statement number. We have, of course, the program name. We tell what we detected. Date time calculation is really quite time-consuming. And down in the button, we suggest what to do in order to improve performance. The program used, or the date calculation used 16 hours CPU time. That's mainly CPU, in order to calculate the number of days invoices were overdue in this very large company. An estimate about the time needed for making the change, and a column chart showing how much time does the job take, how much does the function take, what could we save if we stick it in a memory table instead, is also shown and enables management gives management a solid base for deciding if the improvement should be made. In connection with generating the pages documenting the optimization possibilities, GiAPA also produces an overview showing the totals of all improvement found here in the green frame. Two separate types of analysis are included. Program functions that can be optimized, just like the one we just showed, and improvement of database access, that is avoiding rereading the same records over and over again, as an example. Down here, you can see that here we found 52 program improvements and 18 file access improvements, and it added up to 46 hours that could be saved. Now, this, of course, is quite a large server. The second fully automatic type of analysis deals with how files are accessed, an area typically containing the most rewarding possibilities for optimization. Each file is analyzed across all jobs using the file. The output is similar to what we showed for programs. File name and number of records are shown instead of a program name and statement number, of course. We tell what we found. Here, we found unblocked writes of a file in QTemp. Not less than 1,765 million times did we see an unblocked write. The savings may in both cases be larger than estimated because program and file usage data is only collected when a job uses more than 4% CPU. In addition, it's impossible to estimate how much other jobs may gain from resources being made available through implemented optimizations. This is just one more example of summary page generated. The interesting point here is that it origins from a server having had GiAPA running 24/7 for years. Many applications had been optimized based on collected GiAPA performance data. But the new fully automatic performance analysis is checking all applications running, including programs believed to run efficiently. It was a surprise even to us to see that close to 42 hours, we have the total here in the button in the green frame, close to 42 hours runtime could be saved within an analysis covering only 2 working days. Potential savings of 42 hours runtime within 2 days may sound too good to be true. However, we must remember that this server had 8 CPUs, so there's 192 CPU hours available each day, meaning that the result only indicate about 10% savings. But this is still not bad considering that no one suspected any significant optimization potential. We, of course, have a special offer for you, a free trial of the automatic performance analysis. It'll run on your server and can be handled, and can handle performance data collected for a maximum of 72 hours, not necessarily consecutive hours. We provide all the documentation needed to download GiAPA and run the analysis, and we estimate that it'll require less than 1 working hour for an experienced operator or programmer to run. The free results will be the total page indicating how much was found, plus the third best optimization hints from programs and the third best from file access analysis. If these results look interesting, the full analysis, including all other GiAPA reports and graphs, based on the data collected, can be ordered at a price of 25% of a GiAPA software license. And this amount will be credited if a license is ordered within 3 months from a free trial. The free trial will be using a simplified menu as shown, only including the relevant options. A password will be supplied for unzipping the downloaded file containing the library, GiAPA library, and the user manual. When the data has been collected, a software security code will be supplied to allow the analysis of the data. Collecting data requires no code. Let's just take one more example. GiAPA users provide us with many good references. The large German logistics company Kühne + Nagel was one of our first customers. They defined a special account to keep track of cost and savings by using GiAPA. 5 years later, they announced in the German IT press that their savings by using GiAPA exceeded €1 million, not including the business benefits obtained by shorter response and runtime. GiAPA offers so much more than what we can show in this brief presentation. We invite you to check our introductory video available in English, German, and Spanish, and to explore the product presentation video also available from the GiAPA homepage. Not having the time to tell you about all the other GiAPA options, let's just say this. Remember that GiAPA stores detailed resource usage data for all jobs and tasks every 15 seconds, plus information about programs and files used every time a job uses 4% within a 4% CPU within a 15 seconds data collection interval. We can even show resource usage from all LPARs on a server in one diagram. No other software stores that much information about the usage of an IBM server. Operations loves GiAPA because independent of what happened, data about who used which resources are always available, so any unusual delays can be explained. Management enjoys the graphs capable of showing trends per application. Development will use GiAPA to ensure that the programs perform well. We could carry on for hours, but let us only say thank you very much for your attention. We appreciate your time and really hope we have sparked your performance interest. For more information, please visit us at www.giapa.com. Thank you so much.
Perfect. Thank you very much, Kaare, for this. This is Torbjörn Appel from Built on Power, who is hosting this event. Again, sorry for the trouble in the beginning. Anyhow, I would like to also let Morten speak a little bit. Morten is the IBM Lab Services specialist on, well, performance specialist, I would say, in EMEA. Very well known in the community and strongly contributing to conference and so on, speaking about performance. Morten, are you there?
Absolutely.
Perfect. Thank you very much for joining as well. So just a short comment. I reached out to you when we start planning this, and you said, "Yeah, I would be happy to participate." Have you any comments about this, the GiAPA?
Absolutely. I do think this is a brilliant tool. Basically, the reason for me to say that is my background working with performance in Europe during the last 17 years in the current job, where I come round and spend a lot of time investigating performance by different customers. Having a tool that actually provides you with solutions like this is brilliant. It basically supports our business partners and our customers, and it makes our customers more happy about IBM I, and that's actually what we want. And I have absolutely no problems that different tools can help, because I work in also other areas and applications, because I go in and work with the work management, with the infrastructure when IBM I is working or running on a system together with other partitions. You have external or internal storage. It's connected with the IO server or not. All of that can give issues, including the communication challenges over lines and so on. So that this is just a very good tool that helps the application development and find the bottlenecks. So I think it's a brilliant tool. I've seen it a number of times. So that was basically my comments. Of course, I could start talking about that we have iDoctor and we have ACS Access Client Solution that supports you in the SQL area. But you probably know that, or we can take that another day. Thank you.
Perfect. Thank you very much for that, Morten. And I agree. And I think we also discussed that the GiAPA, you find like 80% of the issues, and then bring in some specialists like Morten for the rest. and so on. And as you said, Morten, there is more into performance than just the software. Anyhow, thank you very much. Simon, do you want to do some closing? Say something?
Yeah, I would also thank from the event part. I would also thank everybody for joining. I do think this was, for me, it was a very interesting topic. I hope this was for everybody else on the call as well, for the same case. And yeah, just to remind you, we will have the next lunch and learn next week, Friday. This will be then on output management together with Interform. So stay tuned. And if you found this interesting, then please enroll also in the other lunch and learn that we're hosting next week. And with that, I would thank everybody and wish you a good day.